Hi, this week we're going to start chapter 13, which is simple linear regression. This chapter will be divided into two parts. The first part, which I'll do the first video on, basically explains what regression models are and helps you set up the initial output in PHStat. And we will start looking at the assumptions of regression, and we will look at something called residual analysis to analyze those. Next week's video is where we actually take the regression output and we then, test this thing to see, if we've got a strong enough model to be useful or not. So anyway, to get started, you should have PHStat opened up in Excel, and the workbook that we're going to look at, which I've already opened up, and I have PHStat also open on my desktop, is the problem at the beginning of chapter 13, where they've got a store called Sunflowers Apparel, and this company somehow profiles customers. I'm not sure what they mean by that. I assume they look at their income levels and other kinds of things, and they count the number of people that meet that criteria within, it says in the book, a 30-minute drive of a sunflower store. So these are in millions, and annual sales is also in millions, but you'll notice the millions are left off through all of our analysis. So when you get to the end, you got to kind of put the millions back on. Anyway, so here's our initial data. They've done this, collected data for 14 stores. They've got the number of profiled customers, and then they've got their annual sales. I made a handout in Word, and we'll post this also. So anyway, you should think very carefully before you just head off and do regression models. They're very easy to do, and it's easy, I think, for people to use regression models and then just assume that what they've got is good because it came out of the computer. So you should have a good look before you just assume that you can run regression. The kind of regression that's looked at in this chapter is single linear regression. Linear means that if you plotted the points in a line fit plot between the two variables that we're looking at, which is our profile customers and our sales, that those dots would look like you could put a straight line through them. You can look on page 428 in the book, and you'll see there are all kinds of other things. So we're looking at panel A or B in the book, but there's also the idea that it could be a curvilinear line, in which point I will tell you from experience that if it's curvilinear and you tell it to run a single linear regression, that is what the computer will do. The computer always does what you tell it to do. So be careful of that. Have a good look at your data before you just assume it's okay. They also, I would assume in that panel C that they've got there, where you just see a scattering of plots and it doesn't look like there's an up or down slope to that line. So if there's really no relationship between the variables, then I would expect it to look like panel C, where you just have no relationship shown. In our regression model, this is the first time this semester that we have looked at the relationship between really two variables. We've looked at populations, for instance, a measure in several different groups, as we did in analysis of variance and t-test and other things. But we've never really looked at the relationship between two numerical variables. So in our two variable model, we have an independent and a dependent variable. The dependent variable, that's the thing that you're trying to predict with your model. And your independent variable is the variable that you're using to predict with. So it makes sense when you think of sunflower stores that they're trying to predict sales using the customers, the profiled customers. So the sales is the dependent variable and the profiled customers is our independent variable. So the first thing you should do before you do anything else is I would go to Excel and create a scatter plot, line fit plot, and then create your PHStat linear regression output. So to do the Excel part of this, You go back to Excel. You do not need pH stat for this. You may be able to create this with pH stat, but it's easy to do in Excel. Also, you just select the two variables, profile customers and annual sales, and you go to insert, and they've got all kinds of charts out here. You've seen most of these things back in chapter 2, I think at the beginning of the semester, but what we want is this line scatter plot or line fit chart. So I just say okay, and I just pick this very first one. So it creates it for us. There are all kinds of things again, you saw this. You can change the colors and make it look pretty. What I would suggest that you probably go ahead and do to this would be if you will point to one of these points, it doesn't matter which one, in this line fit plot, and click on Add Trend Line down here at the bottom. It will ask you, do you want to add a linear trend, exponential trend, and they've got all these different shapes in here. We are looking only for a linear trend. That's what automatically gets checked. If you also move down and select display the equation and display the R-squared value on the chart, it will give you the equation we're going to create with pH stat a little later, but we need the pH stat output. So that's how you create the chart. Once you get the chart created, and I've got it copied over into here, what you're going to do is you're going to have a good look at it. And you just want to make sure that it looks like this straight line would fit through this data. Now, we've got a sample size of 14 here, so it's not a very large sample for regression. But the line looks perfectly okay to me. So I would conclude at this point that it's okay to go ahead and proceed. You should also use pH stat to run the linear regression model, and that file is called site selection, and the file itself is on page 430 in your book, the data in the file, 14 sets of data. So when you go run this in Excel, here's your data. You just go and click on pH stat, and you will look over here and see regression. Pick regression, pick simple linear regression, and then you have to tell it where your dependent variable, your y variable is, and your independent variable, your x variable. So your y variable, remember, is our annual sales. It's what we're predicting. And my x variable, my independent variable, is the profiled customers. So it goes in just like that. Once you've got that done, you're going to select off everything on here except for the very last box. We do not care about a confidence interval at this point. But you want all this other output because we will use it for our residuals. And you say, okay, and things are going to happen. It's going to create a whole lot of other output for you. Once you get this output created, I'm going to go back to Word, and we're going to talk a little bit about the assumptions, and then we're going to go through the residual analysis. So back in Word, there are some assumptions here. And you have to, if you're going to use regression, you have to make sure that as far as you can tell, these assumptions have not been violated. So these 4 assumptions, linearity just says that basically the relationship between the variables is linear in nature, and that if there's error in your model, and there's always error, that is random, and the mean of the error should be 0. In other words, sometimes the model will be above where an actual point is in your data, and sometimes the regression line will be below the point, but it should kind of average out to 0. The second assumption is independence of errors. This is not a problem for the kind of model we're looking at right now, but it could be a problem that you would run into. Typically, independence of errors is something that you have a problem with when you have time series data. In other words, you're looking at the change in sales over time in a specific company. So maybe you've got sales for year 1 through 15, and you use the 1 through 15 as the independent variable to predict sales. And this is problematic because sometimes the value of y for a particular x is related to the value of y for another x. It's time series, you run into problems. But you should get in the habit of checking it anyway. So the values of the error, that's what this E symbol means, error, have to be independent from each other. So there's a way to check for that. Normality of errors. It just says that our errors are normally distributed for each value of x. And we'll check for that. And then equal variance just says that the variance of the errors is the same for all values of x. It's got a fancy name called homodasticity. We'll look at it later. We'll probably not call it that again, but that's what it's called. Anyway, so to get your residual output, some things are produced by pH-stat and other outputs you have to create yourself. So for linearity, the first thing you should look at is your scatter plot again. So the scatter plot and then the plot of the residuals against the x. And pH-stat creates this also when you run it if you checked all the boxes. So your residual plot, again, you should see a scatter plot that looks like a straight line can be drawn through the points on the scatter plot. Then you'll want to go to the tab that says residuals against x in, let's see, which one is that? Residual plot. Yeah, here it is. The residuals against x, I've copied it over into Word, but it's created automatically as part of your output, and it looks just like this. You know, you should expect on page 444, they show some different patterns that you might see with this. Well, no, actually they don't. But you know, you should see something that looks like it's fairly horizontal with a slope of about 0. And I actually put a trend line in here by just pointing at one of these points and clicking on add trend line again. And you know, I added it to this data, and you can see it should look like about half of them are above and about half of them are below. And the line, the trend line, it ought to look like it's like right around there, around 0. So I would say, based on, you know, both of these things, the scatter plot and the residuals against x plot, that this assumption of linearity hasn't been violated by regression. So once you know that, you can move on to the next thing. So the next part of this is to look at independence of errors. Remember, we said this is the one that you usually run into a problem with when you have data that is created by using time series. In other words, you're using time as the independent variable usually. So the way that you test this is with the Durbin-Watson test statistic. Regression in pH-stat will create the calculation, but you still have to look up the values in the Durbin-Watson table at the end of the book. So the error should be independent of each value of x, and Durbin-Watson measures this. We're very concerned with something called autocorrelation. When a positive residual in one time period is followed by a positive residual in the next, or vice versa. So if positive autocorrelation exists, regression is not appropriate for this data. So what you have to do is you have to draw yourself a little table that looks kind of like this one here. This is kind of like a test statistic, sort of. So the Durbin-Watson statistic runs from 0 to 4 with a 2 somewhere in the middle. Looks like my 2 is a little off. I'll move that over so that when you get the output, it'll look a little bit better. And over here, you've got something called a DL and a DU. So that's upper and lower. And the way that you look these up, you go to the Durbin-Watson table, which is on page 652 in your book. And on that table, the K is the number of independent variables. We only have one. This is across the top of the Durbin-Watson table. The N is the sample size. In this case, it's 14, and our table starts at 15. Since we don't have 14, we just use the 15, closest number. So if you look across on the sample size of 15 and down on the K equals 1, you will see a lower a DL of 1.08 and a DU of 1.36. And I put them on my table. So the way that you read this thing is, if you are somewhere above the DU and 4, then autocorrelation, positive autocorrelation will not be a problem. So you don't have to worry about, this occurring. If it's your Durbin-Watson value is between the DL and the DU, then it's questionable. You better go back and just look at it. And if I were not doing time series data, I probably wouldn't be worried, but if I was, I certainly would be worried about it. And if you get below the DL, then you probably got positive autocorrelation, which means this is not an appropriate model to use. You need to go to some kind of non-parametric method. So the Durbin-Watson output from your Excel, again, is, when you look back at Excel, it is all the way here. It's got a tab that says Durbin-Watson. I just copied it over. And if you don't use PHStat, you can create this, but it's a lot of work. You just basically follow the instructions there and get your answer. But anyway, we have a Durbin-Watson statistic of 3.0938, which is somewhere over in here, which means we don't have a problem. So we can kind of go on to the next thing. So autocorrelation, you should check to make sure that you don't have a problem with that. And then the third thing is the normality of errors assumption. And to do this, you use the normal probability plot. Now you have to create this in PHStat. And the way that you do it, I've written it down, but the way that you do it, you go back to your data, all the way over here. And I'm sorry, that isn't right. You go back to your data and you select your the residuals tab. I'm sorry, I'm going the wrong thing here. So there's a tab in here that says residuals, and this is the actual measure. Residual just means error. So this is the actual residual measure. And what you do is you select in PHStat. Remember our where was that at? Data preparation? No. Descriptive. I've forgotten where it was. Under probability and probability distributions, normal probability plot. So you select it. Your variable cell range is just going to be your residuals, the actual residuals. In other words, the actual error that you have between your actual Y and your predicted Y. So this is your actual Y. This is your predicted Y. So it's 5.7 minus 6.46, and they go on. And you just say, okay, and bingo, there's your residual plot. And what I have done is, I again copied this over here, my normal probability plot, and here's my residuals. And I went ahead again, and I just right-clicked on this, and I put a line in here so I could see. Just so I could kind of see what I was doing. So what you would expect to see with this normal probability plot is that this line should go up at about a 45-degree angle above the horizontal axis, and it shouldn't be any pattern there other than, just randomly around the line. So you shouldn't see them, if you've got a large sample size, you shouldn't see it wrapping in and out. You shouldn't see points way away. It should ideally start, I think, at 0, but in this case it starts down a little further, but that's okay. As near as I can tell, again, given our small sample size and looking at this normal probability plot, I don't see any problem with normality of errors. So I would just say there's no problem. Again, you have to check it. Sometimes you don't find anything, which is good, and then when you don't, that's great, and you just go ahead from there. So the last thing we want to look at for this class is the equality of variances assumption. Now you're going to look at both the standardized residuals themselves and the standardized residuals plot, and you have to create both of these things. So I've got instructions here, kind of sort of. I'm going to show you how to do it in Excel. If you go back to your residuals data, and if you go up here, in column F at the top of the page, I'm going to abbreviate standardized residuals as STD. Standard residuals. I will even make this a little wider. And what you do is, it's like a z-score formula. So you are going to need for this particular, this particular set of data, the residuals, you're going to need to create a formula to measure the mean, and then a formula to measure the standard deviation of that. So to do that, again, it's equals average, and then you just take the average of all the residuals and press enter, and you get, again, this e to the minus 16 means that it's engineering scientific notation. E minus 16 means you actually need to move that decimal place 16 places to the left. So it'd be 0.15 zeros and then a 1. So the mean is really small, very close to 0. And then the standard deviation is equals STDEV, and it will automatically do a sample if you just type it in like that. Again, same data, and in my parentheses and press enter, and there's your standard deviation. And I don't care if it's got all those decimal places, that's fine, doesn't matter to me. So your standardized residuals, to actually create that, you're going to take the residual minus the mean, so the actual residual minus its mean, and you're going to divide it by the standard deviation. So I'm going to put this in as an Excel formula. So equals, my residual is here, E2, minus my mean, and I'm going to hit the F4 key because that will make it an absolute cell reference. And I should probably, I'm always careful to put parentheses in, I probably should put my parentheses around there. So E2 minus E16, and you want it always to go back to E16, divided by the standard deviation, which is down here. And again, I want that also to be an absolute cell reference because I want it to go back. So E2 minus E16 in parentheses in the numerator divided by E17. And I press enter, and if I put my data in there correctly, I should have be able to copy that down without doing that but one time. So that's the first thing, is to compute your standardized residuals. Now, to create the standardized residual plot, what you do is you go back to, you copy the standardized residuals. So I'm going to copy them, all of them, copy, and I'm going to go back to the data with my a sheet with my original data on it over here, and somewhere down below under the Y column, which is sales, I'm going to paste it. So I'm going to paste this there. So there they go. And I'm going to then go back and I'm going to copy my X data, my independent variable, and I'm going to paste it right beside down here. So there we got. Now I've got it next to each other. So there's my profile customers to my standardized residuals. And I'm going to then create a scatter plot. So I'm going to select, let me escape that up there. I'm going to select my profile customers and my standardized residuals. I wanted them next to each other. I'm going to go to Insert in Excel, and I'm going to pick off my scatter plot. There we go. So there's my standardized residuals, and I have copied this, of course, over into Word. So now we're going to look at the actual standardized residuals in this standardized residual plot. So back to Word again. That's all the computations. You should do that. So my standardized residuals are here. I've copied them into my Excel Word, into Word, and you get what we should look for here are values that are above 2 or below -2. And I see one value here, 2.188, that looks above 2. I don't see anything that's below -2. And then, I look at it and, in my standardized residual should have a mean of 0 and a standard deviation of about 1. It's off a little. And then my residual plot, what I should see with that is, and again, I have stuck a linear trend line in here at 0, just so you could see. I don't think I really needed that. But anyway, it should look, again, centered around 0. This is the residual. And these are the values of x down here on the horizontal axis. It should look like about half of them are above and about half of them are below. And again, looking at this, there's the one value above. The plot looks pretty acceptable, so I would probably conclude there's no significant problem with the equalities of variance assumption. Anyway, that's it for this week. And if you, on your homework, will work on this part of it and then save all your output for your problems, then you can then finish it up for next week.